Hi, I'm Skymar Thaler. Today, we find ourselves continuing our journey through the realm of the gas giants. But before we start this adventure, take a moment to click that red subscribe button below and the bell icon next to it for all the latest Rooftops of the Solar System and Rooftops of America updates. Today, we visit the Queen of the Planets, Saturn. Seat thyself sultanically among the moons of Saturn. If you were to ask most people on the street, what's the coolest planet in our solar system? The answer would most likely be Saturn. And why not? It is a stunning sight with those rings, those beautiful, glorious rings that set it apart from all its planetary siblings. Saturn is the ring jewel in our night sky, and humans, well, they've been gazing at it for a very long time. Of the 5 planets that we can see with the unaided eye, Saturn is the most dim and distant. It is 886 million miles away from the sun on average. Here's a fun fact about that. Saturn, of the classic major planets, is the only one that's less bright than the stars. Both the dog star Sirius and Canopus are brighter in magnitude than Saturn. The ancient cultures of Mesopotamia were recording observations of it as early as the 8th and 7th century BC, associating this dim light in the night sky with negative properties, and most intriguingly, with the color black. Its golden color in the night sky may have lent itself to its association with agriculture as well. The Greeks called the planet Kronos, and the Romans Saturn, his Latinized equivalent. Kronos was the god of both time and agriculture. Saturn is still part of our culture to this very day, now as a day of the week, Saturday, originally named by the Romans after the planet. In the modern age, we've had several close looks at Saturn and its moons. The first probe to arrive was Pioneer 11, followed by the seminal Voyager missions. All those were flybys, and they provided some tantalizing views of this ringed behemoth, but at the same time, raising more questions than they answered. Saturn would come into startling focus when the Cassini probe arrived in 2004. Over the next 13 years, our knowledge of this gas giant would increase exponentially as Cassini provided an unprecedented view of the complex and fascinating Chronian system. Appearance-wise, Saturn looms large. It is the second largest planet in our solar system, with a diameter of 72,000 miles. That's 14,000 miles less than Jupiter, the largest planet in our solar system. The difference between those two bodies, though, is in the mass. Jupiter basically has over 3 times more stuff than Saturn does. Saturn is still substantial, though. Think of it this way. If Jupiter takes up half of the remaining mass of our solar system from what is left over from the Sun, then Saturn takes up almost all the remaining half. That size actually worked to our benefit because Saturn is theorized to have played a key role in our solar system's history, one that would be a boon for us, but a bane to others. In a nutshell, when Jupiter formed, it started to spiral closer into our Sun. Fortunately, Saturn formed shortly thereafter and was able to exert enough gravitational influence to slow and then pull Jupiter back into its present position. This is known as the grand tack theory. We've seen effects of this event already. It was the cause of the late heavy bombardment. It's why Mercury is so heavily cratered, why Mars is smaller than it probably should have been, but most importantly for us, it's why Earth turned into being a viable habitat for life as we know it. Saturn calmed down the neighborhood bully, and without its influence, the solar system as we know it would have been a wildly different place. Despite its size, Saturn is the least dense of all the major planets. It's the only planet in our solar system whose average density is less than water. There is a saying that if you had a big enough body of water, Saturn, theoretically, could float. The planet is predominantly made up of hydrogen, about 75% of it, and like Jupiter, that hydrogen does some pretty interesting things in Saturn, particularly as it gets closer to the core, where it turns into a liquid with metallic properties. The remaining 25% of the planet, well, a vast majority of that is helium. And then there is some smaller amounts of methane, water ice, and other trace elements such as ammonia. Also like Jupiter, Saturn is in a bit of a rush to count its days. It rotates quickly, with one Chronian day just under 11 hours long. This rotational speed and its lower gravity gives Saturn the appearance of an oblate spheroid, sort of like a flattened ball. In fact, it is the flattest of all the major planets. Saturn's atmosphere is pretty interesting in its own right. It gets that golden color from that trace amount of ammonia found in its atmosphere. Like Jupiter, it's banded, but the bands here aren't nearly as vibrant as you find on the bigger planet. One thing Saturn does have is storms. The winds here reach speeds up to 1,200 miles per hour, the second fastest yet discovered in our solar system. And those storms, well, during the summer season, they can grow to such size and magnitude that we can spot them from Earth with our telescopes. It's at the planet's poles, though, where things get really interesting. Here you'll find some pretty wild and unique things. Both produce aurorae due to Saturn's magnetosphere and its interactions with its moons. On its south pole, you'll find an eye wall type hurricane, the only one found outside of Earth. It's also the warmest spot on the planet. On Saturn's north pole, you'll find one of its amazing wonders. It's a storm. It was first discovered by the Voyager missions in 1981, but what it actually wasn't determined until a few years later. And it was unlike anything we had ever seen before in our solar system. Saturn's storm is quickly becoming as famous as Jupiter's Great Red Spot. It's known as the hexagon. When we think of storms, we often think of swirling cyclones. What we don't think about is geometric polygons. Imagine the surprise when it appeared that Saturn has done exactly that. While the Voyagers may have first uncovered it, Cassini gave us a much more dramatic view of this incredible feature. This color-shifting storm is absolutely massive. Consider this: each wall of the hexagon measures in greater distance than the diameter of the Earth. And from side to side, it measures a distance of 29,000 miles, over a third of Saturn's diameter. It's thought to have a depth of at least 60 miles, though that's a point that's up for debate. There's a lot to learn about the hexagon, so this storm may be much more complex
than we realize.
The hexagon's formation is still being debated, but one of the theories is it's a combination of factors. Basically, when atmospheric flows deep within Saturn create large and small cyclones that then surround a larger horizontal eastern blowing jet stream near the planet's north pole. This jet stream also has its share of storms. These storms start interacting with each other and effectively restrict the eastern jet and confine it at the North Pole. This process forces the jet stream into the shape of a hexagon.
The hexagon seems to be quite stable, so any astro-pointing journey to the Chronian system is at least going to want to do a flyby so you can take in the magnificence of a storm found nowhere else in our solar system. Saturn would most likely be viewed as a bland counterpart to Jupiter, except for one key factor. Out of all the planets in our solar system, Saturn really knows how to accessorize.
While Saturn has been observed since antiquity, its most distinct feature is more of a recent discovery, only revealing itself with the invention of the telescope. With the advent of that instrument, Saturn quickly became a point of fascination. And honestly, that shouldn't come as a surprise to anyone. The rings of Saturn are one of the wonders of our solar system.
Imagine the thrill of peering through your telescope and taking in Saturn for the first time in all its ringed glory. It's a brilliant sight, one that captivates professional and amateur astronomers even to this very day. All the gas giants have rings, but none of them match Saturn in the size, complexity, or frankly, sheer jaw-dropping brilliance.
It was our old friend Galileo who first spotted Saturn's rings. But because his telescope was rather crude, he couldn't quite make out what they were. He first thought they were moons. Then, a few years later, when he spied it again, what he had seen the first time was gone. Then later, they were back but in a different form. And this time, he thought maybe they were something like arms. It wasn't until almost 5 decades later, when Christian Huygens peered through his telescope, that Galileo's findings were finally determined to be rings. Huygens' findings would fuel controversy, but at the same time excite the nascent astronomy community. Here was something never seen before in the heavens.
The rings haven't always been there, nor are they a permanent feature going forward. On a cosmic timeline, they're relative newcomers to the fold. Here's a fun fact. Mammals, as a species, are at least 70 million years older than the oldest date for the rings. Now, there is some debate on how old the rings actually are, with the oldest ranging back as far as 100 million years, and the youngest only 10 million years ago.
There is some mystery behind them as well, like how did they form in the first place? Well, the general theory is they are the rock and ice debris of comets, asteroids, or moons that were broken up by Saturn's gravity. These chunks range in size from particles of dust to small mountains. They are a system unto themselves, with their own interactions at the planet and the moons, and each ring orbiting at its own speed.
Perhaps the most amazing thing about the rings, and there are many amazing things about the rings, particularly the ones closest to the planet, is despite how expansive they are, how wide they are, they're not very deep. On average, only about 30 feet. Now, that would take you from here to right about here. Think about that. For a structure that is so broad it can be seen millions of miles away, it's only as deep as, say, half a basketball court.
When most people think of the rings, they think of the ones closest to the planet. Named in the order of how they were discovered, these are known as the main rings, called A, B, and C. It turns out, though, that this is only part of the picture, because Saturn's rings would be much grander and larger than we ever imagined. Our understanding of this system increased drastically once space probes were sent to the planet. Pioneer, Voyager, and Cassini all discovered additional rings, numbering now to the F ring and the very distant Phoebe ring. One thing is for certain, though. If humans get to Saturn, the rings are going to be one of the most popular sights to see. They are the most extensive ring system yet discovered in our solar system. It's a wonder that we just happen to be able to witness in our time, because they won't always be there. While Saturn and its rings are both fascinating and mysterious objects for astropointers, they're just the opening act. You can't high point Saturn. For us, the main event is the moons, and Saturn has a wealth of them.
If you're an aficionado of moons, well, then Saturn is your paradise. Nowhere else in our solar system are you going to find as an intriguing cast of characters as you will orbiting around Saturn. It has large ones, small ones, active ones, dead ones, light ones, dark ones, and flat out strange ones.
Saturn's moons are an eclectic bunch, with over 80 discovered so far. Currently, more than any planet in our solar system. The major ones are named for Titans, in Greek mythology the brothers and sisters of Kronos. The smaller ones are named after other figures from Greek, Roman, Gaelic, Norse, or Inuit mythology. They come in all shapes and sizes. A majority of these moons are what we call irregular moons.
You could spend a lifetime exploring the idiosyncrasies of Saturn's many moons. They really are a fascinating assortment. Two of them, Janus and Epimetheus, have one of the more interesting relationships you'll find in our solar system. These two tiny moons literally swap orbital positions with each other every couple of years, always dancing, but careful never to step on each other's toes. And then you have the shepherd moons like Pan and Atlas, these floating raviolis that helped create the gaps between Saturn's rings and maintain their structure to this very day.
The smallest named moon is Aegean, with a diameter less than half a mile. The largest of their irregulars is the wild moon of Hyperion, chaotically rotating around the planet, and surprisingly, not tidally locked due to its orbital resonance with Titan. This is a weird moon to see, its potato-shaped appearance making it look a bit like a wasp's nest in space. There is distant Phoebe, an unusually large, irregular moon way on the outer edges of the system, revolving in its retrograde orbit. Compared to other objects that have been found orbiting around planets at that distance, Phoebe stands out as one of the largest ever spotted. Thought to be a captured object, Phoebe is the answer to another of Saturn's mysteries we'll talk about later.
Here's the crazy thing, though. those moons we just spoke about, those aren't even the ones we're interested in. Of the 13 moons that orbit around Saturn that have a diameter of at least 30 miles, the ones most astropointers are going to be interested in are what we're going to call the Saturn Seven. These are the 7 large, regular, ellipsoidal moons. But even limiting our focus on just these is still going to take us on a wild adventure.
Our journey through the Chronian system will start closest to the gas giant, and we will slowly move outward as we explore the major moons of Saturn.
Our Saturn high-pointing adventure gets off to a rather dramatic start when we visit the smallest and innermost of the Saturn Seven, Mimas. This moon is about 115,000 miles away from the planet, and it zips right around it every 22 hours. Its proximity means that it's tidally locked. And if you were to stand on the planet-facing side of Mimas and look up, well, Saturn would fill the sky.
With a diameter of 246 miles, just under the distance directly from Pittsburgh to Philadelphia, this moon is noteworthy for the fact that it is the smallest object discovered in our solar system that has managed to pull itself into a spherical shape with self-gravitation.
Mimas seems to be right at the threshold of this boundary, though, because it's not quite in hydrostatic equilibrium. It's more of a oval shape. What's even more mysterious about this moon is what it's made up of. It's thought to be mainly water ice. Well, if that's the case, then why does it look like it does? Particularly when you consider where it's located.
With Mimas so close to Saturn, the question then is, why is it not more like Enceladus? Mimas should also be subject to tidal heating. In fact, it should be even more intense, perhaps even like Io, but it doesn't show any sign of that. Where are the geysers or the smooth surface? Mimas is surprisingly geologically dead.
There are a couple of theories on why Mimas might be the way it is. One of them is maybe Mimas just never got hot enough in the first place for the process to start. Or maybe Mimas just isn't dense enough. And then there's the thought that maybe Mimas, despite where it's located, just doesn't get into that tug of war with its neighbors to create the necessary friction to heat it up.
While Mimas may be a dead world on the inside, it definitely has been affected from the outside. Mimas makes its high point quite obvious. Honestly, it would be hard to miss it, as it is found in the heart of the most distinctive feature on the moon. A giant crater that at 86 miles is over a third the diameter of the moon.
Named Herschel Crater, this is the feature that gives Mimas its distinct look. It's also given it the nickname the Death Star because of its similarity in appearance to the Star Wars battle station. It's an absolutely incredible impact site, but what might be most remarkable about it is the fact that it did not crack or shatter Mimas into little pieces.
For prospective astropointers, your goal will be the central peak in the crater. Getting there won't be easy, though. The walls of Herschel Crater stand 3 miles high, while the lowest point in the Chronian system hasn't been determined yet. Herschel Crater has to be one of the main contenders. As you trek across the crater floor, parts of it are at depths of 6 to 7 miles below the surface mean.
What makes Mimas noteworthy is this is the first world we've encountered where the central peak of the impact site is actually the high point. Prior to this, it's always been on the edge of the crater. This just goes to show how powerful that impact actually was.
The peak was formed by the massive amount of energy released by the impact. It literally caused the rock and ice to behave as a liquid. First, all that material was pushed out, but as it encountered resistance from solid structures further away, that material then changed course and pushed back and started to pile up at the point of impact. Then, because of the cold temperature, all that material rapidly cooled, leaving behind the structure we see today. In this case, a mountain reaching the height of 3.5 miles, over 18,000 feet, a rather impressive peak for a moon this size.
While this is the first peak we've encountered of this kind, it's definitely not going to be the last. And Mimas will serve as a pretty good training ground for those future endeavors. There's a couple challenges we have to deal with out here in the Chronian system when it comes to highpointing. The first is our old friend radiation. While Saturn doesn't produce nearly the amount of radiation that its bigger sibling Jupiter does, it's still there. And there's still the cosmic radiation from our star. So proper shielding is always a concern. There's also the fact that we're 900 miles away from our star, so it's gotten colder. Saturn itself has an average temperature of about 285 degrees below 0 Fahrenheit, and the moons are the same, if not colder. So we have to be concerned about that as well. And the last one is rather interesting, and it's because of the size of some of these bodies we're highpointing. Take Mimas, for example. Its gravity is 0.6% of what it is on Earth. So, in other words, if you weigh 200 pounds on Earth, you're going to weigh 1.2 pounds here on Mimas. And that is going to give you some extraordinary leaping and bounding abilities. But keep in mind, physics is still very much in play, so your mass needs to be considered. And finding the balance between those two factors is going to be key to our success.
Once on the summit, you'll be able to take in the entirety of Herschel Crater. Looking up, though, you'll get a fantastic front row view of Saturn, and the closest view we'll get on our journey of its rings. Moving away from Mimas, we get to the newest superstar of Saturn, Enceladus, the second smallest of the seven. It was discovered in 1789 by William Herschel, and its most notable feature for a long time was that it was a very bright, shiny little world. Prior to Cassini, this moon was a bit of an afterthought.
The shininess of Enceladus comes from the fact that it has a very high albedo. Albedo is the measurement of the proportion of solar radiation that is reflected off of a surface. Something like soil or dirt has a very low albedo, whereas something like snow has a much higher one. A good example of albedo in action is getting snowblind or sunburnt on the roof of your mouth during the winter.
Enceladus's albedo, or its reflectivity, comes in at 0.99, making it one of the most reflective bodies in our solar system. This would prove to be a bit of a clue to the moon's biggest secret.
What makes Enceladus so reflective is that it's covered in snow. Where Jupiter's Europa seems to be more of a slush ball floating in space, Enceladus, on the other hand, actually does come across as a snowball in space. Imagine this, a world covered in nothing but fresh powder. It's a skier's paradise.
The big question was how Enceladus was producing all that icy precipitation. It doesn't have an atmosphere or water cycle like Earth. The answer wouldn't be known until Cassini spotted something interesting arising from the moon's south pole. That discovery would skyrocket Enceladus' status from an afterthought to one of the most intriguing moons in our entire solar system. Enceladus will require further surveying to determine its exact highest point, but this isn't a lost cause. It does seem to have some areas of elevation scattered across its moonscape.
Your first instinct may be to head to Enceladus' south pole. And, honestly, that's a pretty good guess. Because with all that tectonic activity going on down there, there should be something worth note. And not surprisingly, there is.
Down here, you'll find the geysers and cryovolcanoes that have brought Enceladus into the limelight. You'll also find a circumpolar range that may have a candidate for the highest point on the moon. If you climb these peaks, you'll be awarded with an amazing view of the famous erupting geysers of Enceladus.
Another potential high point is on the North Pole. One of the big mysteries of this moon is why the North Pole terrain seems to be so much older than any other part of the moon.
While the South Pole is a hive of activity, the North Pole appears to be quite the opposite. The terrain up here is some of the oldest in the solar system. It's heavily cratered, an indication that it's not renewed as frequently. Perhaps among this landscape is a place of elevation that remains untouched by the moon's tectonic activity. Perhaps Enceladus has a revolving high point of sorts as the terrain flexes. Another area of interest for us is another of Enceladus's defining features, its tiger stripes. The tiger stripes are formed from the intense tectonic activity brought about by tidal heating. They look slashed across the surface of the moon, and they reach a height of almost 3,000 feet. For our sake, though, we'll be heading to a different ridge that is not part of the tiger stripes, known as the Samarkand Sulcus. This sawtooth ridge stretches 60 miles with a width of about 6 miles. It is an exceptionally tall ridge for Enceladus. You'll want to bring your crampons and ice axe, as some of the slopes are up to 40 degrees.
Once you reach the crest of the ridge and get to the summit, you'll be at an elevation of around 5,700 feet. The view from up here will allow you to take in a snow-white, evolving, and dynamic world, one that may well be another haven for life here in our solar system.
Departing Enceladus brings us to a trio of moons that could easily be mistaken for one another. Tethys, Dione, and Rhea seem to have been cut from the same mold. They have a number of similarities. Each seems to have a similar composition, mainly made up of water ice. They also have a differentiation in coloring from their leading and trailing sides. And, in an unrelated coincidence, all three of these moons were discovered by Giovanni Cassini.
With this trio of moons, that water ice composition is going to prove to be a bit of a challenge when it comes to identifying the highest point. All three of these moons have been fairly well imaged by Cassini. Despite that, though, more work needs to be done in identifying all the topographical features that these moons have.
Each of these moons has a similar surface uniformity and a similar average span of elevation, ranging on average between 3 miles below to 3 miles above because of their composition, water ice. Each of these moons shows signs of significant global heating at some point in its past. That heat has caused many of the older geographical features on them to relax a bit. Regardless, there are still some fascinating places to be found and adventures to be had. Our first stop will be the innermost of them, Tethys. When first viewing this moon, there are two features that stand out. The first is the absolutely massive crater Odysseus, and the other, found on the opposite side, is the moon-spanning long Ithaca Chasma.
In general, the surface of Tethys could best be described as rugged. Pockmarked with craters, hilly terrain. We've actually had a pretty good look at it. Cassini made several flybys of this world during its mission. And looking at that imagery, we can actually discern several clues on where the highest point on this moon may be.
As you may expect, the potential locations for this moon's high point are related to its most defining features. At the same time, if you were looking for the lowest point in the Chronian system, Tethys would be a pretty good place to start as well. Both its major features would be solid candidates for that title. We'll first look at Ithaca Chasma. This canyon stretches about 1,200 miles, going 3/4 of the way around Tethys. At its widest, it's about 62 miles across, and at its deepest, it drops about 3 miles down. It would swallow the Grand Canyon many times over.
There was a theory that Ithaca Chasma was created when Odysseus Crater was created, that the impact of that event literally cracked the side of the moon. And that would make some sense on the surface, but here's the rub. The timeline doesn't add up. When craters were dated on Tethys, it turns out that Ithaca Chasma was the older of the two. So here's the other going theory, that Ithaca Chasma came about when Tethys lost its orbital resonance with its fellow moon, Dione.
The thought is, if Tethys had a liquid ocean, due to friction being generated between the tug-of-war between Dione, Saturn, and it, that once this resonance was lost, the ocean froze. Since ice expands, it pushed out and cracked the crust from the inside. That tectonic activity created the Ithaca Chasma.
For astropointers, though, what makes this location so appealing is actually the sides of the chasma. There are parts on both sides that rise up at least 3 miles in elevation. And standing on top of these would give you a phenomenal view of the canyon below.
On the other side is Odysseus Crater, and it is massive. It's as wide as the moon of Mimas. It is the largest crater by ratio with the size of its moon that has yet been discovered. Like Mimas, there are questions on how Tethys managed to survive its impact. Frankly, it shouldn't have.
To put this in some perspective, if a proportional event was to have happened here on Earth, then the remaining crater would basically have been about the size of the continent of Africa. Based on imagery, there are parts of Odysseus crater that are as deep as 6 miles below the global average, another contender for the Chronian system low point. One of the big mysteries about this impact is what were the conditions that allowed Tethys to actually survive this potential knockout blow.
Like Herschel crater on Mimas, Odysseus crater is a complex crater formation too. Unlike Mimas, our attention won't be on the center though. Instead, we're more interested in the edge. Despite the viscous relaxation over time, the crater rim of Odysseus still rises to a fairly substantial height.
Tethys may yet be another example where the highest point is not necessarily the same as the tallest mountain. Inside Odysseus crater are the Scaria Montes, a group of massifs that rise up several miles in elevation. In most places, these would be high points. But here on Tethys, the rim of Odysseus crater is still at a higher elevation than these mountains.
It's on the rim of this monster where we'll find one of the best candidates for the Tethys high point. According to imagery and mapping, there are points here that still rise above 3 miles in height over the global average.
While more work has to be done in determining Tethys' actual highest point, one thing can be assured. If you were standing on that rim at an elevation of over 15,000 feet, the view you would have would be absolutely fantastic. You'd be able to take in the vastness of Odysseus crater as it stretches out before you, wrapping its way beyond the horizon.